It's been 6.02 times 10 to the power 23 seconds since I started this experiment. I've worked long, hard hours with this garbage of an assistant. However, I've got most of the components. 1.592 times 10 to the power. To the power of what? This world needs me. I must solve for the mass of the electron.
What's up, fam? So, as you may not or may not already know, Robert Andrews Millikan was an American chemist and physicist who was a physics Nobel Prize receiver. But there's obviously more to it than just that. He was born on March 22nd, 1868, and contributed to a lot towards new atom discovery. He traveled around Germany for a bit, Deutschland, and had 3 kids with his wife, Greta Blanchard. But unfortunately, he died on December 19th, 1953. But obviously, he didn't die by scissors. He actually had a heart attack. But it's okay because his name lived on through many buildings, such as the Robert A. Millikan High School in Long Beach. You see, he performed a similar experiment to my homeboy J.J. Thomson, but unlike Thomson's water drop experiment, where he unsuccessfully tried to discover the mass-to-charge ratio of an electron, my new homeboy, Robert A. Millikan, was actually successful with his findings. So, Thomson, he kind of lost. Now, follow me. After working long enough as a court reporter and earning enough money, he entered Oberlin High College in 1886. When he was studying his undergraduate courses, his favorite subjects were Greek and mathematics. He taught elementary physics for 2 years, and it was then that he realized his passion for physics. He later went on and studied at Columbia University, where he was designated as a fellow in physics in 1893. To get his PhD in 1895, before finally teaching as a professor at the University of Chicago.
Good morning, students. I am your new teacher today, and I will be teaching you physics. Any questions? No? Okay, by the way, my name is Mr. Miller. I'm really honored to teach you. You're a very smart one.
The majority of his studies were actually focused on cosmic rays, which is a term that he came up with himself. He continued on to write several more books, such as The Theory of Optics. And later on in life, he was a Christian and remained an ultra-conservative. He thought of science as evolutionary rather than revolutionary, and he'd often oppose some of his own scientific findings and even the National Science Foundation. So as you can see, he was quite the controversial figure back in the day, to say the very least. So now that you're all caught up with Millikan and his life, this is the lab, which he conducted his oil experiment in. Oil, not water, because he's not stupid, like Thomson. Stupid oil.
Hi, I'm Robert Millikan. Today, you may know me because of my oil drop experiment. I decided to conduct this experiment because I'm a curious soul, and because I have lots of free time, and I don't have a life. Yeah, so I will be using oil instead of water, unlike Thomson, because those stupid and pesky H2Os won't evaporate, and so it'll be easier for me to calculate the mass of electrons. Okay, So in 1897, J.J. Thomson found out that electrons actually exist and they have a negative charge. But because he's not as awesome as me, he couldn't find out the quantity of the charge. So me and my buddy Harvey Fletcher designed an experiment where we took oil and sprayed some fine mist in between the plates of a capacitor. A capacitor is basically a device that stores electric charges. So we placed a microscope into the capacitor so we could observe the oil droplets activity. So here's a picture of what the contraption looks like. My assistants will explain it now. Now obviously, some of the oil drops would fall down to the ground because duh, gravity. But if I change the voltage, some droplets will go back up. This is because the electric force would be stronger than the force of gravity. Now, if I altered the electric voltage to the right amount, I could find a happy middle where the electric force and gravity would equal the same amount. The drops would flow. From there, I knew all the variables such as voltage and mass and etc. Except for the charge. I made an equation out of that and I found that the value was E equals to 1.592 times 10 to the negative 19 coulombs. Strikingly similar to today's present value, E equals to 1.602 times 10 to the power negative 19 coulombs. I mean, not that I would know since I'm supposed to be dead now, but whatever. So, I was able to indirectly measure the charge of an electron and then mathematically figure out the mass of it. I know, call me a genius already. Thank you. So, and did I mention that during World War I, I made a bunch of anti-submarine machinery too. So I'm educated and I helped out during the war. I know, don't worry. You can't become like me. After 7 minutes and 19 seconds of the video, I still have yet to realize the missing component of my equation. But wait, a square has 4 sides. If you slice a square in half, you get 2 triangles. A triangle has 3 sides. 3 times 3 equals to 9. 9 plus 10 is 19. My assistant is feeling very sad today. Sad is a negative feeling. -1 is also negative. -1 times 19 is -19. The puzzle is solved. The answer to the question of life is 1.592 times 10 to the power of -19.